with Lesson 5. Our lesson is about angles, and we'll be starting in Chapter 3 on page 90. The objective for today is to learn the precise definition of an angle, to be able to name and identify parts of an angle, and to be able to measure, draw, and classify angles. Last week we talked about rays. Opposite rays are two rays that are part of the same line and have only their endpoints in common. In the example that we see here, the ray XY and the ray XZ are opposite rays. X would be the endpoint for both of those rays. The figure formed by opposite rays is also referred to as a straight angle, but most of the time we will call it a line. Here is another case where two rays can have a common endpoint. This figure is called an angle. Unless otherwise noted, the term angle in this book means a non-straight angle. Some parts of angles have special names. The common endpoint is called the vertex. The two rays that make up the angle are called the sides of the angle. There are several ways to name the angle shown above. One way is to use the vertex and a point from each side. The vertex letter is always in the middle. So the angle that we see here can be named angle RST or angle TSR. Again, the endpoint S, which is the vertex of the angle, is always listed in the middle. Another way to name the angle is to use the vertex only. This can be done if there is only one angle at that vertex. So, the angle we see here can be referred to simply as angle S. The last way to name an angle would be to use a number if a number is written in between the two sides. So the above angle could be referred to as angle 1. The precise definition of an angle is: an angle is a figure formed by two non-collinear rays that have a common endpoint. We see this angle here can be named angle DEF, angle FED, angle E, or angle 2. Let's look at this example. Name this angle in 4 ways. Then identify its vertex and its sides. The angle can be named angle ABC, angle CBA, angle B, or angle 1. Its vertex is the point B. Its sides are the rays BA and the ray BC. Now you try. Name this angle in 4 ways and then identify its vertex and its sides. Again, this angle can be named DEF, angle FED, angle E, or angle 2. The vertex is the point E. The sides are the ray ED and the ray EF. Try this one. Name the angle in 4 ways. Identify its vertex and its sides. I'll give you a minute to think about it. All right, we can have either angle GHI, angle IHG, angle H, or angle 3. The vertex is the point H. The sides are the ray HG and the ray HI. How'd you do? Now look at the figure at the right. 3 angles have the point P as their vertex. Whenever there is more than one angle at a given vertex, we have to use 3 points or a number to name an angle as shown at the right. We cannot simply name any of these angles by the vertex P. So angle 1 is the angle MPN. Angle 2 is the angle NPO. And we have a third angle, which is the larger angle, the combination of angles 1 and 2, the angle MP0. O. Do you see all three of them? Let's name all of the angles here that have W as their vertex. There are 3 distinct angles with the vertex W. We have angle 3, angle 4, and the larger angle, which is the combination of 3 and 4, angle XWZ. What are other names for angle 3? Could be angle XWY or angle YWX. It doesn't matter which order we start with, as long as we put the W in the middle. What are some other names for angle 4? We have angle YWZ or angle ZWY. What are other names for the angle XWZ? There's only one. We can reverse the order that we start with, and it can be angle ZWX. Is there an angle that can be named simply angle W? No. Again, remember, if several angles all have the same vertex, we cannot simply just call an angle W. You try it. Name all angles having W as their vertex. Go ahead and write it on a sheet of paper if you need to pause, and then hit play again when you've put down what you think the angles are. We have angle 1, which could also be called angle AWB, angle 2, which can be called angle BWC, and we have the larger angle AWC. Again, we could reverse the order of the letters, and so we might find 3 more names for the different angles. Try this one. We've added another angle. Name all the angles having W as their vertex. We have angle 3 or RWS, angle 4, SWT, angle 5 would be angle TWU, and then the larger angle, which includes all of them, would be angle RWU. Again, we could call it UWR. Now, an angle separates a plane into 3 parts: the interior of the angle, the exterior of the angle, and the angle itself. In the figure shown, point W and all other points in the blue region are in the interior of the angle. Point V and all other points in the yellow region are in the exterior of the angle. Points X, W, and Z are on the angle. Tell whether each point is in the interior, exterior, or on the angle. In problem 3, we see that point D is in the interior of the angle. In problem 4, point E lies on the angle. It can lie anywhere on the angle, including the vertex. Point F is in the exterior of the angle. You try it now. Tell whether each point is in the interior, exterior, or on the angle. Problem E has point R, and point R is on the angle. Problem F is looking at point S, and point S lies in the interior of the angle. Problem G has point T. T lies in the interior of the angle. In geometry, angles are measured in units called degrees. The symbol for the degree is the little circle placed at the top right of the number. The angle shown measures 75 degrees. In the notation, there is no degree symbol with 75 because the measure of an angle is a real number with no unit of measure. This is summarized in the following postulate. For every angle, there is a unique positive number between 0 and 180, called the degree measure of the angle. Once the measure of an angle is known, the angle can be classified as one of three types of angles. These types are defined in relation to a right angle. A right angle is one that measures 90 degrees. A 90-degree angle has one ray, which would be a vertical line, and one ray, which would be a horizontal line. The two rays will be perpendicular to each other. And again, they form a 90-degree angle. An acute angle is an angle which measures between 0 and less than 90. An obtuse angle is one which measures between 90, well actually greater than 90, up to or equal to just before 180. So an obtuse angle is going to be greater than 90 degrees. Let's classify each of the angles we see below. A 110-degree angle is an obtuse. It's greater than 90. Problem number 5 shows us a 90-degree angle. Again, we refer to this as a right angle. In problem 6, our angle measures 40 degrees, clearly less than 90, so we refer to it as an acute angle. Your turn. Problem D, we have a 50-degree angle. How do we refer to this? We classify this angle as acute. Problem E has a 130-degree angle. How would you classify this one? Again, greater than 90 is going to be classified as obtuse. F is a 75-degree angle. What do you think? You got it. It's acute, less than 90. Earlier in this section, we studied some geometric tools. Another tool we use in geometry is called a protractor. You can use a protractor to measure angles and to sketch angles. There are different types of protractors, but they are all used in the same way. We need to become familiar with these terms. The center mark is the little circle on the zero edge where we will be placing the protractor over the vertex of our angle. The zero edge is a straight edge, and we will be lining up one of our rays on that zero edge. We have two scales on a protractor, an inner scale and an outer scale. Stop and identify these places on your protractor. When we're measuring an angle, we're going to place the center mark of the protractor on the vertex of the angle. Place the cross at the vertex of the angle if you have this type of protractor. Now, rotate the zero edge of the protractor to line up with one ray of the angle. The other ray of the angle will cross the protractor scale. We're going to read from the zero on the outer scale of our protractor. Zeros can be on either side of the protractor or only on one side, like this. Now we're going to read the measure of the angle of the ray where it crosses the protractor scale. If the ray on the zero line is to the right of center, read the inside scale. If the ray on the zero line is to the left of center, read the outside scale. Count the degree lines carefully. The line might fall between degrees. Pick the mark that it is closest to. Is the measure of this angle 130 or 50 degrees? Well, we said that if the angle ray was to the right of center, we would read the inside scale. So this angle measures 50 degrees. Is this angle measure of 20 or 160? Again, the ray that lines up on the zero edge lies to the left of center. So we're going to read the outside scale. That means that this angle measures 20 degrees. How about this one? Is it 70 or 110? Which direction does the ray line up with on the zero edge? It lies to the right of center, so we're going to read the inside scale, and we have a 110 degree angle. On your worksheet, use a protractor and measure angles CDF. Go ahead and pause the movie if you need to, and then hit play when you're ready to give me an answer. This angle should have measured 40 degrees. On your worksheet, find the measure of each of the angles, PQR, PQS, and PQT. Hopefully you got 45 degrees for the angle PQR, 100 degrees for the angle PQS, and 150 degrees for the angle PQT. Now, use your protractor to draw an angle having a measure of 135. Begin by drawing a ray YZ. Use your straight edge. Place the center point of your protractor on Y. Align the mark labeled 0 with your ray. Make sure ray YZ lines up on your zero edge. Now, locate and draw a point X at the mark that's labeled 135. Now remove your protractor and use your straight edge to draw the ray from the point Y to the mark that you made for the point X. Depending on the type of protractor you're using, the mark can go inside the protractor in the inner arc, or you can put your mark outside of the protractor on the outer angle. Try this one. Use a protractor to draw an angle of measure 65. Again, use your straight edge to draw the horizontal ray. Place your protractor over the ray. Line it up on the zero edge. Make the mark on the inside at 65. Remove your protractor and use your straight edge to draw a ray from the vertex to your mark. We can also practice our algebra skills with our angles. If we are told that the measure of angle B is 138, and we also see that the measure of angle B is 5x minus 7, we can make an equation by setting 138 equal to 5x minus 7. To solve for x, we'll add 7 to both sides. That gives us 145 equals 5x. We'll now solve for x by dividing both sides by 5, and we find that x is equal to 29. Let's try constructing angles of the same measure. This is going to require using a compass and a straight edge. Your first step will be to draw an angle like the one that you see, angle P, on your paper. It really doesn't matter what the measure of that angle is. Got it? Now use a straight edge to draw a ray on your paper. Label the endpoint T. Use your compass now. Place the point at the vertex P. Draw a large arc with your pencil side of your compass. This arc should intersect both sides of angle P. Label the points of intersection Q and R. Now, take the compass and leave it at the same setting that you just had it. This time put the point on the vertex T, or the endpoint T, of the ray that you have already drawn. Draw a large arc that starts above the ray and intersects the ray. Label the point of intersection S. Place the point of the compass on the point R from angle P. Adjust it so that the pencil tip now lies on the point Q. Now, again, don't change the setting of your compass. Place the point at point S and draw an arc that will intercept the larger arc that you drew in step 4. Label this point of intersection U. Put your compass down and draw a ray TU using your straight edge. The two angles that you have should be the same measure. How did you do? Again, good job on another long lesson. Your practice work for tonight is page 92 through 94, problems 1 through 23 odd, and page 100, problems 4 through 22 odd, also problem 23 and 24.